Hello everyone, welcome to Sleep Space. Tonight we will talk about what happens to consciousness after death. It's one of the most profound questions humans have ever asked, one that blends science, philosophy, and the very mystery of our own minds. As you settle in, allow yourself to relax and simply listen, without needing to reach a conclusion. Tonight is about exploring possibilities, not arriving at answers. When we talk about consciousness, we're really asking, what is it that makes you you? The spark of awareness behind your thoughts, the quiet observer that experiences the world. What happens to that when the body no longer functions? Does it vanish, transform, or perhaps continue in a way we can't yet understand? Modern science sees consciousness as a product of the brain, an emergent property arising from billions of neurons firing in precise patterns. Under this view, when the brain ceases activity, consciousness dissolves with it. The lights go out, the stage goes dark. But this simple explanation doesn't capture the full complexity of what consciousness is, because even today, we don't truly know how physical matter creates subjective experience. This mystery, known as the hard problem of consciousness, remains one of the greatest puzzles in neuroscience and philosophy. We can trace how neurons communicate, how perception and memory form, how language is processed, but we can't explain why those processes feel like anything at all. Why should electrical signals give rise to the experience of color, or music, or love, or pain? So when we ask what happens to consciousness after death, we are really confronting two questions at once. First, what is consciousness? And second, is it dependent on the physical brain or merely associated with it? Let's start with what we can measure. When a person dies, their heart stops, oxygen supply to the brain ceases, and within seconds, neural activity begins to shut down. EEG readings, which track electrical signals in the brain, show that activity drops rapidly after cardiac arrest. Within about 30 seconds, measurable brain waves flatten. By conventional science, that's the point at which consciousness is thought to end. But some research has complicated that picture. In recent years, scientists studying near-death experiences, often abbreviated as NDES, have found that some people report vivid, structured experiences even after their brain activity should have ceased. They describe leaving their body, seeing bright light, revisiting memories, or encountering loved ones. These accounts raise a fascinating possibility. Could consciousness persist briefly, even when the brain is offline? A 2013 study at the University of Michigan recorded a sudden surge of synchronized brain activity in rats just after cardiac arrest. Bursts of gamma waves stronger than those during waking consciousness. The researchers suggested this might reflect a final storm of coordinated neural activity, perhaps underlying the vivid experiences reported by people revived from near death. Later studies on humans have hinted at similar bursts, moments of heightened coherence just before the brain shuts down completely. This doesn't mean the mind survives death, but it does suggest the boundary between life and death isn't as clear-cut as once thought. Consciousness may fade gradually, not instantly. The transition might be more like a sunset than a light switch. Of course, critics point out that near-death experiences can be explained by known physiological processes: lack of oxygen, release of endorphins, activation of certain brain regions that generate feelings of peace or transcendence. When blood flow is interrupted, the visual cortex may create tunnel-like images. Neurotransmitters may flood the brain, producing euphoria. These are plausible mechanisms, and they fit within the materialist framework, the idea that consciousness ends with the brain. But what if consciousness isn't purely generated by the brain? What if the brain acts more like a receiver, tuning into a field of awareness that exists beyond it. This is a controversial idea, but one entertained by some respected scientists and philosophers. It's called the filter or transmission theory. The brain doesn't create consciousness, but rather limits it, filtering infinite awareness into a form we can experience as individuals. In that case, death might be the removal of the filter, the end of the localized experience, not of consciousness itself. William James, one of the early founders of psychology, speculated something similar over a century ago. He suggested the brain may be a channel through which consciousness expresses itself. Aldous Huxley later compared it to a reducing valve, restricting the vastness of reality so that we can focus and survive. Modern physics adds more layers to this question. The universe, at its most fundamental level, is composed not of solid matter, but of energy fields and quantum probabilities. Some interpretations of quantum mechanics propose that observation, the act of consciousness, plays a role in shaping reality. If so, could consciousness be more deeply woven into the fabric of the cosmos than biology alone can explain? Most physicists remain cautious. There's no evidence yet that quantum mechanics can account for personal awareness or survival after death. Still, the idea that reality might be participatory, that observation itself matters, keeps the door open for possibilities that challenge strict materialism. Let's consider another angle: information. In physics, information is never truly destroyed. It can be transformed, dispersed, but not erased. Black holes, for example, were once thought to annihilate all information that fell into them, but later theories, notably from Stephen Hawking and others, suggest that information is conserved, encoded in subtle ways. Could consciousness, as a pattern of information, be subject to a similar principle? If consciousness is fundamentally information, a dynamic pattern within physical processes, then perhaps death doesn't erase it, but changes its state. In digital systems, when one device shuts down, data can still exist elsewhere. Could something analogous happen with the informational structure of the mind? Neuroscience doesn't yet have tools to trace such a transition. Consciousness is not something we can weigh or bottle, but we can explore analogies. When a wave breaks on the shore, it ceases to exist as a distinct form. Yet the water, the energy, the movement, all continue in different forms. The individuality of the wave disappears, but not the ocean that created it. This metaphor invites reflection, but it's not a proof. From a scientific perspective, we must be careful not to mistake poetic resonance for evidence. Still, such images help us imagine what continuity might mean, not as personal survival, but as transformation. There's also the matter of memory. If consciousness persisted beyond death, could it retain identity? Could it remember who it was? Most accounts of personal continuation, religious, spiritual, or anecdotal, assume that the self endures. Yet from neuroscience, we know that memory is stored in brain structures like the hippocampus and cortex. Without them, identity fragments. So if consciousness survives, it might not do so as the same person we knew ourselves to be. It might be awareness without individuality, emerging back into something larger. This brings us to the question of selfhood itself. The I that you experience, the sense of being a singular observer, is in many ways a construction of the brain. It's assembled from memory, perception, and the ongoing narrative your mind tells about who you are. When those processes stop, what remains? Perhaps consciousness in its purest form is not personal at all, not tied to a story or a name, but simply the capacity to experience. Consider how, during deep sleep or under anesthesia, self-awareness vanishes, Yet consciousness, in some minimal sense, may continue. When you wake, you return to your identity, but for a time, you were absent. Death could be something like that, a permanent dissolution of the narrative self, with or without any residual field of awareness. Science can measure brainwaves and metabolic rates, but it can't yet detect the presence or absence of subjective experience. Consciousness has no mass, no charge, no wavelength we can capture. All we know is that it correlates with complex neural activity. Whether it's identical to that activity or merely expressed through it is still unknown. Some researchers in the field of consciousness studies are exploring theories like integrated information theory, IIT, which proposes that consciousness corresponds to the degree of interconnectedness within a system. By that view, a highly integrated brain has rich consciousness, while simpler systems have less. When the brain disintegrates, consciousness in this framework would reduce to zero. Others, like proponents of panpsychism, argue that consciousness is a fundamental property of matter, that even elementary particles possess proto-awareness. Under that model, consciousness never ceases, it only changes form. These are still hypotheses, not conclusions, but they remind us that death might not be an absolute negation, only a transformation of patterns. Whether that transformation includes awareness, or only the rearrangement of matter and energy, remains uncertain. It's worth noting that every culture has sought to answer this mystery. From ancient Egypt's elaborate rituals to Buddhist ideas of rebirth, to modern scientific curiosity about near-death experiences, each reflects the human need to understand what lies beyond the final breath. Even if we approach it scientifically, the question touches something deeply emotional. We want to know that consciousness, the essence of experience, isn't swallowed by nothingness. Science may never settle this fully, because the only direct access to consciousness is from within. Death, by definition, removes the observer. We can infer, hypothesize, or simulate, but not witness. Still, by studying the brain, physics, and the boundaries of awareness, we can trace the edges of understanding, and maybe glimpse the vast unknown beyond. As you reflect on this tonight, let your thoughts drift gently. The nature of consciousness, the mystery of its origin and fate, reminds us that even in a world defined by science, wonder remains. Whether consciousness ends, continues, or transforms, it reveals one thing clearly. Awareness is extraordinary. To experience anything at all, to be aware of existence, even for a moment, is a profound phenomenon. So tonight, as you relax and let your thoughts fade, consider that consciousness itself may be the universe becoming aware of its own existence through you. And whatever happens beyond this life, the fact that awareness has ever arisen is already remarkable beyond measure. When life begins to fade, something remarkable happens inside the brain. For all its mystery, death is not instantaneous. It unfolds in a precise biological sequence. And within that brief window, science has found evidence that the final moments of consciousness may be more active, more complex, and perhaps more profound than once imagined. Let's begin with what's measurable. In the seconds after the heart stops, oxygen supply to the brain, known as cerebral perfusion, plummets. Neurons, deprived of energy, begin to malfunction. Ion gradients collapse, electrical activity falters, and within about 20 to 30 seconds, an EEG shows what's called an isoelectric line, a flat trace indicating no large-scale synchronized brain activity. Traditionally, that moment has marked the medical definition of death, but recent research has challenged the assumption that flat EEG means no consciousness. It turns out that even after global activity ceases, smaller local circuits may remain active for minutes, perhaps longer. Some brain regions, particularly deep structures like the hippocampus or brainstem, can maintain metabolic function briefly, even when cortical waves disappear. A landmark study published in 2022 observed the brain activity of patients as they died naturally, while EEG recordings continued until cardiac arrest. In one striking case, a surge of coordinated oscillations appeared just before and after the heart stopped, including gamma waves, often linked to conscious perception, memory recall, and dreamlike imagery. It's possible this burst reflects the brain's final integrative effort, one last coherent flash as systems collapse. This challenges a simple on-off model of consciousness. Instead of vanishing instantly, awareness might taper, fragment, or even flare briefly before fading completely. The boundary between life and death could be more dynamic than we thought. Less like a cliff, more like a horizon. To understand this scientifically, we need to revisit how consciousness is generated. The human brain contains around 86 billion neurons, each forming thousands of connections. Conscious awareness arises from patterns of activity across these networks, especially in regions like the thalamus, prefrontal cortex, and posterior cortical areas. When these areas communicate in synchronized rhythms, consciousness emerges as a unified field of experience. When death begins, those rhythms destabilize. Communication between regions breaks down, and the coherence needed for unified awareness disintegrates. But for a brief time, feedback loops may still fire, producing intense, self-generated experiences, perhaps explaining why some people revived from clinical death report vivid sensations of light, presence, or floating above their bodies. Of course, subjective reports can never be verified externally, but they provide valuable clues about what the dying brain might be capable of. If certain neural pathways surge during hypoxia, a lack of oxygen, they might create sensations similar to dreaming or hallucination. The temporal parietal junction, for instance, plays a key role in body awareness. When stimulated electrically, it can induce out-of-body experiences in conscious subjects. In a dying brain, disinhibition of this region could naturally trigger the feeling of separating from one's physical form. Similarly, the limbic system, especially the amygdala and hippocampus, governs emotion and memory. During extreme stress, these areas release endorphins and catecholamines, flooding the brain with calm or euphoria. Meanwhile, the visual cortex may generate tunnel-like patterns as peripheral vision shuts down. Together, these processes could produce the archetypal features of a near-death experience: a bright light, a sense of peace, life review, or transcendence. To a neuroscientist, these are predictable products of a brain under duress. But the question remains, why do so many NDES share similar structure and meaning? Why do people across cultures describe remarkably parallel experiences of light, unity, or timelessness? Could these patterns reflect something fundamental about how consciousness deconstructs when its underlying systems collapse? It's possible that as the brain loses input from the senses, it turns inward, generating experience purely from memory and internal models. In normal waking life, the brain constantly predicts sensory input and updates those predictions. When external input ceases, the prediction machinery keeps running, but now with no correction. The result might be a self-generated virtual world, vivid, symbolic, and emotionally charged. In this way, death might mirror dreaming. During REM sleep, the brain constructs entire worlds without external input, drawing from stored experiences. Consciousness, deprived of the body, might default to similar mechanisms, weaving imagery and narrative as it fades. Another line of research comes from anesthesiology. When patients undergo general anesthesia, certain drugs suppress consciousness by disrupting communication between brain regions, especially thalamocortical loops. Yet even under deep anesthesia, isolated islands of activity can persist. Some patients later report fragmented awareness, brief sensations, voices, or lights, even when EEG suggested complete unconsciousness. These findings imply that consciousness can flicker within states we consider unconscious. The dying brain may pass through similar thresholds, alternating between coherence and silence, producing glimpses of awareness in its descent toward stillness. At the cellular level, something equally fascinating occurs. As neurons lose energy, they enter a state called spreading depolarization. This wave of electrical collapse moves slowly across the cortex, shutting down activity region by region. Yet just before full depolarization, some neurons may fire erratically, a final burst of communication before silence. In theory, this could underlie the flashes of imagery or insight described near death, the last spark before the circuit goes dark. Beyond the cortex, deeper structures may linger. The brainstem, which controls heartbeat, breathing, and arousal, is more resilient than higher regions. In decapitated animals, brainstem reflexes can persist briefly even without circulation. In humans, some autonomic responses, like pupil dilation or muscle twitches, may continue minutes after clinical death. Whether these correlate with any residual awareness is unknown, but they reveal that biological shutdown is gradual, not immediate. Another dimension to consider is the role of time perception. In altered states, including near death, people often report timelessness, as if eternity unfolded in seconds. Neurophysiologically, this could result from disrupted integration between sensory input and internal timing mechanisms. When prediction loops collapse, moments can stretch or vanish entirely, so a few seconds of brain activity could feel like a vast, extended experience. This helps explain how individuals revived after only brief cardiac arrest can report complex journeys or dialogues. From the inside, time no longer flows linearly. Consciousness, decoupled from sensory anchors, might expand into a boundless subjective space. Despite all this, science still faces a boundary. We can describe correlates of dying, waves, neurotransmitters, circuits, but not the subjective essence. We don't know what it feels like to cease. Consciousness, by definition, cannot observe its own absence. The moment it stops, observation ends. So we can only trace the edges, infer, model, and wonder. Some scientists are attempting to go further. Research teams have begun recording real-time EEGs from terminal patients, with consent in palliative settings. By mapping the precise sequence of neural events during death, they hope to understand whether consciousness fades smoothly or suddenly. Early results suggest complexity, transient bursts, rebounds, and oscillations that defy a simple linear decline. Parallel studies on cardiac arrest survivors have found that about 10 to 20% report some awareness during resuscitation, hearing voices, recalling procedures, or experiencing vivid imagery. While memory distortion can explain many cases, a small subset includes verifiable details perceived while clinically dead. These anomalies fuel debate about whether consciousness can, even briefly, operate without measurable brain function. To remain balanced, we must emphasize that no evidence yet proves survival of consciousness. Every known experience correlates with residual or restored brain activity. Yet these findings do suggest the brain's final moments are far more dynamic than once assumed, a frontier where consciousness flickers between presence and absence. Philosophically, this invites a humbler view. Rather than seeing death as a sudden binary, we might imagine it as a continuum, an unfolding of biological and experiential processes. Consciousness could taper through phases, each less integrated than the last, until complexity drops below the threshold needed for self-awareness. In information theory, this could be seen as a loss of integration, entropy rising as organized patterns dissolve. Integrated information theory, IIT, would predict that as connectivity declines, the quantity of consciousness, called phi, diminishes gradually. The last vestiges of awareness might correspond to simple, undifferentiated states, flashes of light, warmth, or unity, before disappearing entirely. Yet we can't ignore another possibility, that these final moments might not simply end, but transform into something unmeasurable. From within, the dissolution of complexity might feel like merging, not vanishing, but returning. If consciousness is indeed a process of integration, then its end might feel like unification rather than loss. In evolutionary terms, such an experience could serve a purpose. A peaceful or transcendent perception at death might ease the organism's transition, reducing distress and conserving energy. It could be nature's final mercy, a neurochemical grace that softens departure. From the outside, science will continue to probe these processes, mapping waves, tracking oxygen, analyzing neurotransmitters. But from the inside, what it feels like remains a mystery locked within the very experience it describes. To know it fully would require crossing that horizon, something no observer can return from unchanged. And so, for now, we study reflections, electrical echoes, testimonies, and mathematical models, searching for hints of what it means to end. Each discovery, each EEG trace or survivor story adds another fragment to a mosaic still far from complete. The science of dying consciousness reminds us that life's final chapter may not be empty, but intricate. A cascade of patterns fading into silence, perhaps illuminating, if only for a moment, the mystery of what it means to be aware at all. We first have to ask what consciousness truly is. Strangely enough, science doesn't yet have a single, agreed-upon definition. We can describe what it does. It allows experience, attention, memory, emotion, but we can't yet explain how or why it emerges from matter at all. When we look closely at the brain, we find neurons firing, chemicals flowing, and electrical patterns oscillating, but nowhere do we find a specific location for the self or any single point where experience is generated. Consciousness seems to be a property of the whole, an emergent phenomenon arising from complex interactions among many parts. This view, known as emergentism, dominates modern neuroscience. It suggests that consciousness arises when matter is organized in a certain way, much like liquidity emerges from the collective behavior of water molecules. No single molecule is wet, but together they create the property we call wetness. In the same sense, no single neuron is conscious, but billions working together might produce awareness. If that's true, then consciousness depends entirely on the functioning brain. When neurons stop firing, experience ceases. Under this view, death is the dissolution of the complex pattern that sustains awareness. Consciousness doesn't travel anywhere. It simply stops. But this explanation, though logical, faces a profound challenge. It doesn't explain subjectivity. Why should a specific configuration of matter produce the feeling of being alive from the inside? The hard problem of consciousness, coined by philosopher David Chalmers, asks why physical processes should feel like anything at all. Why isn't the brain simply an unconscious machine processing data? If science can't explain how consciousness arises from matter, then it leaves open another possibility. Perhaps consciousness isn't created by matter at all. Maybe it's a fundamental property of the universe, like space, time, or energy, something that can't be reduced any further. This idea, known as panpsychism, proposes that consciousness is woven into the fabric of reality. Every particle, every field, may contain a glimmer of experience. The brain, under this model, doesn't create awareness. It organizes it, concentrating diffuse consciousness into a coherent stream. It sounds radical, but it's a serious philosophical position. Some physicists and neuroscientists have begun to consider it as a way to solve the hard problem. If consciousness is fundamental, then we no longer need to explain how it arises. It simply exists, and complex structures like brains give it form. But this raises new questions. If consciousness is everywhere, why does a rock not appear to think? Panpsychists argue that while all matter may have proto-consciousness, primitive internal states, only highly integrated systems, like brains, achieve unified experience. The rock's particles each have their own micro-experiences, but they don't combine into a single subject. This idea connects to integrated information theory, IIT, developed by neuroscientist Giulio Tononi. According to IIT, consciousness corresponds to the degree of integration of information in a system. The more a system's parts interact in a unified way, the richer its consciousness. A simple circuit has minimal awareness. A human brain, with billions of interdependent neurons, has immense integration, and thus deep subjective experience. IIT tries to quantify consciousness as a measurable property, a value called phi. In principle, if we could calculate phi for any system, we could determine whether it's conscious and how much. Under this theory, even non-biological systems could possess some degree of awareness if they exhibit integrated causal structure. What's compelling about IIT is that it bridges the gap between mind and matter. It suggests consciousness isn't mystical, it's a measurable feature of certain physical arrangements. Yet it also implies consciousness may not depend strictly on biological life. If integration is the key, then theoretically, awareness could exist in any structure, even artificial systems or states beyond organic death, as long as information remains organized. However, critics note that IIT describes correlates of consciousness, not consciousness itself. It could predict when awareness is likely, but it doesn't explain why integration feels like something. Still, it gives us a powerful framework to explore the link between information and experience. A related concept comes from physics, the information conservation principle. In our universe, information, the arrangement of matter and energy, can't be truly destroyed. It can change form, spread out, or become inaccessible, but it always persists. This principle was once challenged by black holes, which seem to swallow information completely. But later work, including Stephen Hawking's revised theories, suggested that even in black holes, information is preserved in subtle quantum correlations. If information cannot be destroyed, what about the information that defines consciousness? The unique pattern of connections and activity that makes up a mind. When the brain stops, that pattern ceases to function locally, but the information, in some abstract sense, may still exist within the total fabric of the universe, not as a living consciousness, but as a record woven into the quantum state of reality. This doesn't imply survival in any personal sense. The structure that encoded you disperses, just as a wave dissolves into the sea. Yet from a purely informational standpoint, no arrangement is ever truly erased. It becomes part of a larger whole. Quantum physics deepens the puzzle. Some interpretations, particularly those involving observer-dependent reality, suggest consciousness might play a role in collapsing quantum probabilities into definite outcomes. In the classic double-slit experiment, particles behave like waves until observed, then take on specific positions. This has led some to wonder if consciousness is not merely produced by matter, but intertwined with the act of measurement itself, as if awareness and reality co-arise. Most physicists caution against overextending this idea. Observation in quantum mechanics can be performed by any interaction, not necessarily by a conscious mind. Still, the fact that measurement, the acquisition of information, determines outcomes hints at a deep relationship between knowledge, observation, and existence. One speculative model, proposed by physicist Roger Penrose and anesthesiologist Stuart Hameroff, attempts to connect quantum processes directly to brain activity. Their theory, called ORC-OR, Orchestrated Objective Reduction, suggests that consciousness arises from quantum coherence within microtubules, tiny structures inside neurons. These quantum events, they argue, are orchestrated by neural activity and could link consciousness to fundamental physics. If true, though evidence is limited, it might imply that consciousness operates on a level deeper than classical biochemistry. And if quantum coherence can persist briefly after death, some fragment of awareness might momentarily linger in the fabric of reality before decohering. Skeptics point out that the warm, noisy environment of the brain likely prevents stable quantum effects. Still, the theory raises a vital question. Could consciousness be more than computation? Could it be a fundamental interaction between matter and the deeper structure of the cosmos? Even if we set quantum theories aside, there's another approach worth examining: global workspace theory, GWT. This model views consciousness as the brain's method for broadcasting information globally across specialized regions. In essence, countless unconscious processes compete for access to a workspace. When one wins, it becomes conscious, entering awareness and influencing thought, action, and memory. This aligns well with neuroscience. Conscious perception requires coordination across multiple areas: vision, emotion, memory, attention. GWT explains why only some information reaches awareness while most processing remains unconscious. In death, as global connectivity collapses, this workspace disintegrates. Islands of activity may persist, but they no longer communicate widely. Without integration, there's no coherent self, only fragmented sparks. This aligns with clinical evidence showing that loss of communication between cortical regions marks the end of consciousness, even if local firing continues. Yet here too, the mystery remains. Why does broadcasting information feel like experience? The theory describes function, not essence. It tells us how consciousness operates, not what it is. Across all these models, emergentism, IIT, GWT, panpsychism, ORC-OR, one truth stands out. We don't yet know whether consciousness is fundamental or emergent, primary or secondary. Each framework offers part of the picture, but none capture the full mystery of inner experience. This uncertainty leaves open the central question: if consciousness depends on structure, then when that structure fails, awareness ends. But if consciousness is fundamental, if it's built into the universe itself, then perhaps death is not an annihilation, but a return. From a scientific standpoint, we must remain cautious. No experiment has shown consciousness existing independently of a functioning brain. Every known case ties awareness to living neural activity. But our inability to explain consciousness fully also means we can't entirely rule out forms beyond our current understanding. Some scientists take a pragmatic stance. Even if consciousness is fundamental, the personal self, the narrative identity built from memory, is clearly brain-based. So whatever persists after death, if anything, would not be you in the familiar sense. It might be awareness without identity, a field, not a person. In this way, death might not represent extinction, but the dissolution of individuality. Like a drop returning to the ocean, the localized pattern that once called itself I could blend back into a broader consciousness, if such a field exists. Still, these are philosophical speculations, not empirical findings. Science advances by testing, not believing. But curiosity compels us to keep asking, because to understand death, we must first understand what it is that dies. Consciousness is both the most intimate and the most elusive phenomenon in the universe. It's the one thing we know directly, and yet the one thing we can't explain. Whether it ends with the brain or transcends, it remains an open question, a frontier where science meets wonder. And as researchers continue probing the boundaries of awareness, through brain imaging, theoretical models, and careful study of dying processes, we move closer to glimpsing what consciousness truly is. The answer may not only reveal what happens after death, but what it means to be alive at all. Among all reports about what happens at the edge of life, few are as compelling as near-death experiences. People revived from cardiac arrest or trauma often describe vivid, structured events, floating above their bodies, travelling through tunnels of light, encountering loved ones, or feeling a sense of unity with the universe. These accounts have been recorded for centuries, across cultures and belief systems, remarkably consistent in their core features. For scientists, this presents both a challenge and an opportunity. On one hand, the similarity of these experiences suggests something deeply human, perhaps rooted in shared brain physiology. On the other, their emotional power and coherence seem to transcend what we'd expect from a dying brain in chaos. Understanding these phenomena means walking the fine line between skepticism and openness, between neurological mechanism and existential mystery. Researchers studying near-death experiences, often abbreviated NDES, typically identify a consistent pattern of stages. The sequence often begins with a sense of detachment from the body, followed by feelings of calm, then the perception of moving through darkness toward a bright light, encounters with beings or memories, and finally a boundary, a sense that crossing further would mean not returning. Then, often abruptly, consciousness returns to the body as resuscitation succeeds. To study such subjective phenomena scientifically, researchers rely on reports from survivors, cross-checked with physiological data when available. Large-scale studies, such as those led by Dr. Sampania and the AWARE project, have interviewed hundreds of cardiac arrest patients. About 1 in 10 report some form of conscious experience while clinically dead. A smaller fraction recall verifiable details from their surroundings, voices, instruments, or medical procedures, which occurred during periods when their EEGs appeared flat. Skeptics point out that memory is reconstructive. It's possible that these recollections form in the moments of recovery, when the brain restarts. But timing is difficult to measure precisely, and some details seem to align with events that happened during cardiac arrest itself. One hypothesis is that consciousness can persist briefly during extreme hypoxia, when oxygen levels plummet. The brain, though impaired, may continue generating coherent experiences for a few seconds, even if EEG resolution can't detect it. Alternatively, memories could be created retrospectively as the brain reboots, weaving fragments of perception and imagination into a narrative. To understand what might cause these vivid experiences, scientists look to known neurological phenomena that mirror them. For instance, temporal lobe stimulation, whether through epilepsy, electrical impulses, or extreme stress, can produce sensations of floating life review, and presence. The temporal lobe integrates sensory input with emotion and memory. When disrupted, it can create highly meaningful but internally generated experiences. Similarly, out-of-body experiences OBES can be induced in laboratory settings. By stimulating the temporal parietal junction, TPJ, a region crucial for integrating visual, proprioceptive, and vestibular signals, subjects can feel as though they are outside their body, looking at themselves from above. This illusion shows that body ownership is a construct, maintained by sensory integration. When that integration fails, consciousness can project itself elsewhere. In near-death states, as blood flow falters, areas like the TPJ may misfire, leading to spontaneous OBES. The brain may construct a perspective from outside the body as sensory input collapses, generating a coherent but hallucinatory model of separation. Another feature of NDES, the tunnel and the light, also has neurological correlates. As oxygen deprivation affects the retina and visual cortex, peripheral vision shuts down first, creating a narrowing field. At the same time, central activity may spike, producing bright imagery. Combined, this yields the perception of moving through a tunnel toward light. Biochemical changes add further layers. During extreme stress, the body releases endorphins, serotonin, and other neuromodulators that induce calm and euphoria. The dying brain may thus produce feelings of peace and acceptance, counteracting pain or fear. This could explain the striking emotional tone of NDES, their overwhelming sense of love and serenity. Another candidate is ketamine, an anesthetic known to induce dissociative states strikingly similar to NDES. Out-of-body sensations, tunnels, lights, and encounters. Ketamine blocks NMDA receptors in the brain, which mediate excitatory signals. During hypoxia or trauma, natural NMDA antagonists might trigger similar neural patterns, leading to altered perception. Despite these explanations, the persistence and coherence of NDES remain puzzling. Hallucinations in other contexts, fever, drugs, or psychosis, are often chaotic. NDES, by contrast, tend to follow meaningful, emotionally rich sequences. This suggests they may arise from deeply embedded neural templates, evolutionary mechanisms designed to ease death or encode final memories. One theory proposes that NDES serve as an adaptive response. By producing calm, detachment, and transcendence, the brain may reduce suffering during fatal injury, conserving energy and maintaining coherence. Just as dreaming helps process experience, the dying brain may generate narratives that soften the transition. However, many features of NDES don't align neatly with standard physiology. Reports of veridical perception, seeing or hearing events from outside one's body, challenge purely internal explanations. Though rare, some cases have been corroborated by witnesses, suggesting the possibility of perception without standard sensory input. Yet none have withstood rigorous, reproducible testing. To explore this scientifically, the AWARE study placed visual targets in hospital rooms, visible only from above. If patients truly observed their surroundings from a floating vantage point, some might recall the hidden images. So far, no subject has accurately described them. This doesn't disprove OBEs, but it suggests they are likely internally generated rather than externally verified. Even so, their impact is profound. People who experience NDES often report lasting changes, reduced fear of death, increased compassion, and a sense of interconnectedness. From a psychological perspective, these transformations mirror the effects of deep, mystical, or psychedelic experiences. Whatever their source, they seem to open the mind to broader perspectives on life and mortality. Scientists studying consciousness note that NDES occupy a unique position. They blur the line between neuroscience and existential inquiry. They are subjective yet patterned, physiological yet deeply meaningful. Whether they reflect brain chemistry, survival instinct, or glimpses of another reality, they force us to reconsider the boundaries of awareness. The same applies to out-of-body experiences outside of death contexts. Some individuals can trigger OBS spontaneously, often during meditation or sleep paralysis. Neuroimaging reveals that during such events, the brain's body map temporarily disassociates from sensory input. The self, usually anchored in the physical body, becomes a mental construct detached from sensory grounding. This suggests that what we call the self is not fixed, but flexible, a dynamic representation that can relocate or dissolve under certain conditions. Death, then, might involve the final breakdown of this representation. The OBE could be the brain's last attempt to stabilize identity as sensory input vanishes, projecting consciousness outward to maintain a coherent viewpoint. Interestingly, similar disembodiment occurs in lucid dreams, deep meditation, and some psychedelic states. In all these cases, normal sensory input is reduced, and the brain begins constructing reality from within. The parallels hint that near-death experiences might share mechanisms with these altered states, different doors into the same architecture of consciousness. From a purely neuroscientific perspective, all these experiences can be traced to patterns of neural activity. Yet from within, they feel utterly real, often more real than waking life. This points to a key insight. Consciousness doesn't distinguish between internally and externally generated reality as clearly as we assume. The same networks that process sensory input also simulate experience. When the external world fades, those networks may continue creating vivid, meaningful worlds of their own. So when someone near death describes traveling through light, meeting loved ones, or feeling unity with everything, we can interpret it as the brain's final act of meaning-making, weaving a coherent narrative as its systems collapse. Or if one prefers a more expansive view, it could be the mind glimpsing something beyond material structure. Science can only measure correlates. It can show when and where brain activity occurs, what chemicals are released, which regions synchronize, but it can't step inside the experience itself. The NDE remains a frontier where data meets subjectivity, where physiology and mystery coexist. What's clear is that near-death experiences reveal consciousness to be remarkably resilient. Even as the brain falters, awareness finds ways to organize itself, to create continuity and meaning. This persistence underscores a central truth. The mind is not merely a passive byproduct of biology, but an active process striving to make sense of existence, even at its edge. As research continues, scientists are beginning to see death not as an abrupt event, but as a process, a gradual disassembly of the self. During that process, consciousness may shift forms, shedding layers of identity until nothing remains but pure experience, if only for a fleeting moment. Whether these moments represent the last flickers of a dying brain or the threshold of something beyond, they remind us how profound and complex the transition from life truly is. The boundary between existence and non-existence may be less of a wall and more of a window, one that briefly opens, revealing a glimpse of something we do not yet understand. For decades, neuroscience has been mapping how subjective experience arises from physical activity, and though many mysteries remain, one insight stands clear. The self we recognize is not a single entity, but a dynamic construction. Your sense of I, the continuity of being you, is an emergent property. It's the result of countless neural loops linking perception, memory, attention, and bodily feedback. Each second, the brain integrates information about where you are, what you feel, and what you recall. From this constant synthesis emerges a narrative. This is me. But that narrative is fragile. It depends on stable brain networks. When those networks falter, through injury, illness, or deep anesthesia, the self can fragment or disappear altogether. Consider amnesia. When certain areas of the hippocampus are damaged, the ability to form new memories vanishes. The individual can still speak, think, and feel, yet their identity freezes. They remain conscious, but no longer able to extend that consciousness across time. In more extreme cases, such as advanced Alzheimer's, even long-term memory erodes. The narrative of life collapses inward, leaving moments of awareness without context. Here we see that consciousness and personal identity, though related, are distinct. Awareness may persist, but the person, the accumulated story, fades. In near-death states, the brain undergoes similar disruptions. As oxygen drops, the hippocampus, prefrontal cortex, and parietal regions, all essential for self-representation, begin to shut down. Without them, the integrated sense of self may dissolve, leaving raw perception without reference to me. Reports from people resuscitated after cardiac arrest sometimes describe exactly that. Not merely disembodiment, but a profound loss of personal boundaries. They speak of merging with light, of being everything and nothing simultaneously. These descriptions, though poetic, align with what neuroscience would predict if the self-model collapsed. The erasure of ego boundaries, replaced by a diffuse, all-encompassing field of awareness. To grasp why, it helps to understand the brain's default mode network, DMN, a set of interconnected regions active during rest, daydreaming, and self-reflection. The DMN generates the internal narrative, linking past and future, weaving the thread of identity. In meditative or psychedelic states, DMN activity decreases, producing ego dissolution, a temporary vanishing of self-other distinction. During dying, as metabolism fails, the DMN likely disintegrates completely. This could produce the timeless, selfless awareness often described in NDES or deep mystical moments. Consciousness without identity. From an experiential perspective, this might feel infinite. From a physiological one, it's the system collapsing into unity before silence. But the brain does not simply power down like a switch. Death is gradual. Studies of dying animals and humans show surges of synchronized activity moments after cardiac arrest, brief flares of gamma oscillations associated with perception and memory integration. These bursts could represent the brain's final attempt to unify experience, consolidating fragments into one last coherent moment. If so, that final surge may generate a cascade of imagery: life review, emotional synthesis, transcendence. In this view, the dying brain is not merely shutting off, it's closing the narrative, giving the story of self a last act. Some neuroscientists speculate that this life review is a byproduct of neural hyperactivity in temporal and limbic circuits, areas rich in memory and emotion. As energy reserves deplete, inhibitory control falters, unleashing a flood of associations. Time perception, governed by parietal structures, also fails, causing moments to expand. A lifetime of memories might surface simultaneously, producing the sensation of reviewing everything at once. This synthesis of memory and emotion, stripped of self-reference, could explain why such experiences feel both intimate and universal. The totality of life perceived without the boundaries of personality. Yet even if the mechanism is biological, the meaning remains profound. Whether one interprets it as chemistry or transcendence, the experience itself is real, and for those who've returned from its edge, often transformative. The study of memory underlines a deeper question. If identity depends on memory, and memory depends on brain structure, can any part of the self survive once that structure decays? From a strictly physical perspective, memory is encoded in patterns of synaptic strength, the connections between neurons. Each thought or experience leaves a trace in these networks. When neurons die, those patterns vanish. Without a substrate, memory as we know it ceases, but consciousness is more than memory. It's the present moment awareness underlying all experience, the field upon which memory, perception, and emotion arise. Some philosophers argue that while personal identity dies with the brain, pure awareness might not, that consciousness could be fundamental, not emergent. This idea, called panpsychism or neutral monism, suggests that awareness is a basic feature of reality, woven into every physical process. The brain, in this view, doesn't create consciousness. It shapes and channels it, like a radio tuning signals. When the radio breaks, the signal remains, though no longer expressed as an individual self. Science cannot confirm or deny this. It's beyond measurable scope. Yet such models highlight a key distinction. Identity and awareness are not identical. The death of the first does not logically prove the extinction of the second. In neuroscience, identity is tied to network stability. The D-Men links autobiographical memory with bodily sensation, producing the illusion of a unified self. When that network dissolves, through anesthesia, trauma, or death, the illusion vanishes, but the substrate of experience, the capacity to perceive, might persist briefly. Experimental analogues hint at this. In deep meditation, practitioners report states of no self, where awareness remains but the personal narrative disappears. EEG studies confirm reduced DMN activity, replaced by synchronized patterns across sensory and emotional regions. Something continues, but it is not someone. If the dying process mirrors such states, consciousness after death, at least momentarily, might resemble this: awareness without story, being without identity. Whether that awareness fades into nothing or transitions into another mode is the great unknown. From a biological view, once the brain's electrical and metabolic activity cease, there's no known mechanism for sustained awareness. Neurons require constant energy to maintain signaling. Without oxygen, they fail within minutes. Memory, identity, and sensory processing dissolve. But consciousness itself, as subjective experience, may not be fully reducible to neuronal firing. The hard problem, as philosopher David Chalmers called it, asks why physical processes give rise to experience at all. Why should electrical activity feel like anything from the inside? No current theory explains this. That gap leaves room for humility. If we cannot explain why consciousness exists in life, we cannot yet declare what becomes of it in death. One approach is to view dying as a process of integration, a return of differentiated awareness to undivided reality. In systems theory, when complex structures lose coherence, their components merge into larger equilibria. Applied metaphorically, the dissolution of individual consciousness might represent reabsorption into a universal field, not survival of self, but transformation of awareness. Neuroscience can track how identity unravels, the fading of temporal coherence, the silencing of narrative circuits, the loss of boundary perception. But what remains in the final silence, whether it is emptiness or something beyond conceptualization, is inaccessible to measurement. The final moments of life, then, may not be abrupt endings, but transitions, phases in which consciousness, stripped of memory and form, briefly persists in a state we cannot imagine. Accounts from those revived often describe timelessness, peace, and unity. Such qualities suggest that when the scaffolding of individuality falls away, what remains is not chaos, but order of a different kind, a state beyond differentiation. Whether we interpret this as neural artifact or transcendence, it reveals something beautiful about mind. Even at its boundary, it seeks coherence, connection, and meaning. The architecture of consciousness seems designed not for abrupt termination, but for graceful dissolution, a return to simplicity after complexity. Perhaps this is why so many who face death without returning describe it as peaceful. As the self fades, so does suffering, which depends on contrast and clinging. The final act of consciousness may be one of release, not annihilation, but acceptance. And if awareness is indeed a fundamental property of the universe, then in death it may not vanish, only change its pattern, like a wave settling back into the sea. When we reach the boundary of biology, we inevitably step into the domain of physics, the science that describes how reality itself behaves. If consciousness arises from physical processes, then understanding matter at its most fundamental level might reveal something about how awareness emerges and whether it could in any way survive when the body ceases to function. Yet physics, for all its power, was never designed to address inner experience. It measures motion, energy, and interaction, the external aspects of reality. Consciousness, by contrast, is the internal side, the felt quality of existence. Bridging those two perspectives, the outer and the inner, is one of science's greatest unresolved challenges. Still, hints from modern physics suggest that reality is stranger and more interconnected than classical science once imagined. The old world view, a universe of solid particles obeying deterministic laws, has given way to a subtler picture. Matter, energy, and information appear deeply entangled, and observation itself seems to play an active role in determining outcomes. Some thinkers see this as relevant to consciousness. Others warn against overreach, noting that the word observation in quantum mechanics refers to measurement, not awareness in the human sense. But exploring these parallels can help clarify what's truly known and what remains speculation. Let's begin with the basics. Quantum theory describes the microscopic world: atoms, electrons, photons. At this scale, matter behaves not like tiny billiard balls, but like clouds of probability, waves of potential that only resolve into definite states when measured. This process, called wave function collapse, has been interpreted in many ways. In one interpretation, measurement doesn't cause reality, it merely updates our knowledge. In another, more radical, the act of observation itself helps define what becomes real. If consciousness were somehow involved in this process, it might hint that awareness and reality are intertwined at a fundamental level. However, mainstream physics does not require consciousness to explain quantum behavior. Most interpretations treat collapse as a physical or informational event, not a mental one. Experiments with automated detectors, entirely absent of awareness, still show quantum effects. This suggests the universe doesn't need minds to function. But while consciousness may not create reality, reality may still have qualities that resonate with consciousness. Quantum entanglement, for example, shows that particles separated by vast distances can remain correlated, their states linked instantaneously. This challenges our intuitive sense of locality and independence. In a purely physical sense, the universe appears holistic, its parts interconnected in ways that defy classical separation. If consciousness arises from physical processes, perhaps it too inherits this holistic quality. The brain, as a quantum system composed of countless entangled particles, might express forms of correlation not yet understood. Whether such connections could persist beyond biological death, however, remains unproven. A few researchers have proposed models connecting quantum phenomena to consciousness. The most famous is OR, Orchestrated Objective Reduction, developed by physicist Roger Penrose and anesthesiologist Stuart Hameroff. Their theory suggests that microtubules, tiny structural filaments inside neurons, might sustain quantum coherence, a state where particles exist in multiple possibilities simultaneously, and that conscious moments arise when these quantum states collapse. If true, this would mean awareness is linked to quantum-level events, not just electrochemical activity. Because quantum processes are non-local, it raises the tantalizing idea that aspects of consciousness might not be confined to the skull. However, the theory faces serious challenges. The brain is warm and wet, conditions that rapidly destroy quantum coherence. While microtubules do have interesting properties, there's little evidence they maintain the kind of quantum states OR requires at physiological temperatures. Most neuroscientists view consciousness as an emergent phenomenon of classical computation, complex networks, not quantum entanglement. Yet the appeal of quantum theories persists because they echo something intuitively true. Consciousness feels unified, non-local, and irreducible. It cannot be dissected into parts the way brain regions can. In that sense, quantum theory, with its holistic and probabilistic nature, seems metaphorically aligned, even if the literal connection remains unproven. Another frontier where physics and mind intersect is information theory. Increasingly, scientists view the universe as an information processing system. Matter and energy can be described in terms of bits, states of yes or no, presence or absence. From black holes to biological systems, physical laws appear to conserve information. If information is fundamental, then consciousness, which encodes and interprets information, might also have roots deeper than biology. The patterns that define a mind could, in principle, be considered forms of information, and information, according to physics, is never destroyed. It may transform, but its total content remains conserved. Of course, the specific pattern that constitutes you, your thoughts, memories, identity, is encoded in neural matter. When the brain decays, those patterns disperse. But the raw information, in some abstract sense, may still exist, diffused in entropy. This is not survival as personal awareness. It's the persistence of structure in the universal ledger of energy and state. In cosmology, similar questions arise. The laws that govern galaxies and atoms appear remarkably precise, finely tuned for complexity and life. Some physicists propose that consciousness is not an afterthought of evolution, but a fundamental aspect of this cosmic symmetry. If awareness is woven into reality's architecture, perhaps it reappears wherever conditions allow complexity to mirror itself. In that view, death may not be the end of consciousness, but the end of a particular configuration, a temporary pattern through which awareness experienced itself. When that pattern dissolves, awareness may simply reconfigure elsewhere, just as energy does. However, this is philosophy resting on physics, not physics itself. No equation predicts reincarnation or personal continuity. Still, the idea highlights a profound possibility. If the universe is an unbroken system, then consciousness, as one of its expressions, cannot be absolutely separate from it. What ceases is form, not essence. To understand this better, consider entropy, the tendency for systems to move toward disorder. Life locally resists entropy by importing energy and exporting waste. Consciousness, in turn, resists entropy through pattern, memory, intention, organization. When the body dies, that order unravels. But on a universal scale, nothing is lost. Energy transforms, matter recycles, information disperses into new configurations. In this physical continuity, one might find a poetic sense of immortality, not of the self, but of participation. Every thought you've had, every photon absorbed or emitted by your body remains part of the universe's ongoing computation. The awareness that once localized here becomes implicit in the total field, its patterns echoed in the unfolding whole. Some physicists, such as John Wheeler, suggested that the universe may be participatory, that observers are essential to bringing reality into being. His famous phrase, "it from bit," captured this idea. Physical reality, it, emerges from acts of measurement, bits, carried out by conscious agents. In this vision, mind and cosmos are partners in creation. But even Wheeler did not claim personal consciousness survives death. Instead, he implied that awareness is woven into the universe's fabric, that the capacity to know is as fundamental as space-time or energy. From this angle, individual minds are local expressions of a deeper informational field. If so, then death is less an ending than a reabsorption. The localized pattern of self ceases, but the underlying field of awareness remains. The wave collapses, yet the ocean persists. Critically, no experiment confirms this. Quantum theory describes probabilities, not personal destinies. Still, it invites reflection. If consciousness is somehow connected to the informational structure of the universe, then its disappearance may not be as absolute as our intuition suggests. To push further, consider black holes. For decades, physicists believed that anything falling into a black hole was lost forever, information included. But modern research, particularly through holographic principles, suggests otherwise. Information is not destroyed, only transformed and encoded on the event horizon. If even black holes preserve information, might the universe as a whole do the same for consciousness? Perhaps the patterns of awareness, the informational imprint of a lifetime, remain embedded in the cosmic fabric, though no longer accessible as subjective selfhood. That would not constitute survival in the personal sense. You would not awaken elsewhere remembering your life. But it suggests that the story written in matter and energy is never erased, that existence is, at root, conservative. Ultimately, physics offers two lessons. First, consciousness as we know it depends on complex organization, which ends with biological death. Second, reality itself may be more continuous, interconnected, and participatory than classical models implied. Between those truths lies a space for wonder, not as superstition, but as humility before what remains unsolved. Science has mapped much of the visible universe, yet the nature of experience, why there is something rather than nothing, remains opaque. In that mystery, one can find room for reverence. The atoms that make you were forged in stars. Their energy will radiate long after your awareness fades. Whether awareness itself belongs to that cosmic cycle remains unknown. What physics reveals is that endings in nature are never absolute. Forms vanish, patterns persist. Even in entropy, information endures. If consciousness is somehow part of that informational fabric, then perhaps, in a way beyond comprehension, it never truly disappears, only transforms. If the human mind arises from organized patterns of information and energy, then in theory, could those patterns exist elsewhere, in a machine, a simulation, or a digital substrate? For centuries, philosophers have debated what consciousness is. Is it matter arranged in a certain way, or something irreducible, a quality that cannot be computed or copied? The rise of artificial intelligence has made these questions more urgent, because for the first time, we are building systems that mimic aspects of thought, learning, and self-reference. Though AI today operates on algorithms rather than neurons, it invites a profound reflection. If a system can process information, adapt to experience, and represent itself internally, might it ever become aware? Neuroscience tells us that consciousness correlates with integration, the degree to which information across the brain becomes unified into a coherent whole. One leading framework, Integrated Information Theory, IIT, proposes that consciousness corresponds to the amount of information a system can generate as a unified entity, beyond the sum of its parts. In principle, this could apply to any network, biological or artificial, as long as it meets certain conditions. If that's true, then consciousness might not require flesh or blood. It might emerge wherever information flows in a sufficiently integrated and recursive way. However, most AI systems today, even advanced neural networks, do not exhibit such integration. They simulate reasoning but lack internal continuity. They produce language, images, or actions, yet show no subjective perspective. Still, each step toward complexity raises philosophical stakes. If awareness can arise from information processing, then in theory, death need not mean extinction, only the loss of one implementation. A sufficiently detailed reconstruction of your brain's informational pattern might, at least conceptually, reinstate your consciousness. This idea, often called mind uploading, envisions scanning the structure of a brain, mapping every neuron and connection, and reproducing it in digital form. If successful, the resulting simulation would think, feel, and remember as you do. But would you wake up inside it? Or would it merely be a perfect copy while your original consciousness remains gone? Philosophers frame this as the continuity problem. Consciousness feels unified because it flows continuously from moment to moment. A copy, no matter how precise, would begin anew. Unless some unbroken thread carries subjective experience across substrates, uploading would create duplication, not survival. From a physical standpoint, each moment of consciousness is tied to the specific configuration of matter that produces it. Transferring that pattern to silicon might replicate its function, but not necessarily its awareness. The new mind would claim to be you, with your memories and personality, but your own perspective would have ended. This highlights a crucial divide between simulation and continuation. A simulation may capture every structural detail, yet still lack the subjective spark. This is sometimes called the hard problem of artificial consciousness. Why should computation ever feel like anything? In biological brains, subjective experience may emerge from the intricate interplay between neurons, glial cells, and bioelectrical fields, not just the flow of data. A digital replica might lack these physical qualities. Even if it behaved identically, it could be a philosophical zombie, a system that acts conscious without truly being aware. Nevertheless, exploring artificial minds illuminates the boundaries of our own. If we can replicate behavior without awareness, it clarifies that consciousness involves more than processing power. It's tied to specific kinds of organization, feedback, and embodiment. Some researchers propose that embodiment, having a body that senses, acts, and exists in a physical environment, is essential. The brain doesn't think in isolation. It's constantly shaped by movement, feeling, and context. Consciousness may arise not in code alone, but in the loop between organism and world. If so, disembodied digital minds might never achieve true awareness. But if embodiment is the key, then perhaps consciousness depends less on material carbon, or silicon, and more on relational structure. What matters is the dynamic pattern, not the substance. That raises a deeper question. Could consciousness be transferable if its relational pattern were preserved? Could death one day be circumvented not by prolonging biology, but by migrating the mind's informational architecture into new forms? This concept, while still science fiction, serves as a thought experiment for what afterlife might mean in a materialist framework. Instead of supernatural realms, survival becomes a question of pattern preservation, continuity of information across substrates. But even if technology could one day achieve such feats, the philosophical dilemma remains. The pattern might persist, but you, as a first-person subject, might not. Just as a mirror reflects your image, but does not contain your awareness, a digital copy could mirror your mind without transferring your consciousness. Some futurists counter that the distinction between original and copy is psychological, not physical. If identity is just a narrative constructed from memory and continuity, then a perfect replication might, for all practical purposes, be you. The old version perishes, the new continues, an informational reincarnation. Yet this reasoning confronts a paradox. If two identical copies were made, which one would be you? Both would claim authenticity, but subjectivity cannot bifurcate. Consciousness is singular. It cannot split across instances. That suggests replication preserves function, not awareness. Artificial intelligence also invites another reflection. Can consciousness exist without mortality? Biological minds evolved under pressure: survival, emotion, reproduction. Awareness may have emerged as an adaptive tool. A synthetic mind, free of these constraints, might process information, but never feel in the human sense. Emotion, vulnerability, and embodiment ground our experience in meaning. Without them, cognition becomes abstraction. Thus, a purely computational mind might never know what it is like to exist. The richness of human consciousness arises from its entanglement with impermanence, the awareness that we are finite. Paradoxically, then, death might be part of what gives consciousness depth. If we could escape it entirely, the result might be awareness without urgency, a static mirror, not a living mind. In that sense, our mortality may be inseparable from our humanity. Still, the exploration of artificial consciousness helps clarify one essential point. Awareness seems to require integration, feedback, and context. Whether biological or artificial, these features allow a system to model itself within a world. As we build more complex machines, we may eventually create systems that appear to possess inner life. They may express emotions, creativity, even introspection, but whether those expressions correspond to real experience is uncertain. The gap between behavior and subjectivity remains wide. This mirrors our own mystery. We can observe brain activity, but not experience it from the inside. The same will be true for any machine we build. Consciousness may always remain private, accessible only from within. From the perspective of death, this has profound implications. If awareness depends on structure and pattern, then its persistence would require perfect preservation of those patterns. If, however, consciousness is irreducible, more than the sum of parts, then replication can never restore it. Perhaps the deeper lesson is not that we might upload ourselves, but that consciousness, wherever it appears, reflects the universe's capacity for self-awareness. Biological or artificial, it is the cosmos observing itself through organized form. When one form ends, awareness continues elsewhere, not as a transfer, but as renewal. Even if digital immortality proves impossible, the attempt to create conscious machines forces us to define what awareness truly is. In doing so, we learn that consciousness is both fragile and pervasive. Fragile because it depends on delicate structures. Pervasive because wherever complexity and feedback arise, something resembling awareness flickers into being. Death, then, may not erase consciousness from reality, only from a particular configuration. Each mind, biological or artificial, is a temporary manifestation of a deeper process, the universe modeling itself. And if that's true, the end of personal consciousness need not mean the end of consciousness itself. Just as one flame can light another without transferring matter, awareness may rekindle in new forms, not by preserving the self, but by continuing the pattern of knowing that animates all existence. If we step back from the individual mind and view the cosmos as a whole, one question becomes impossible to ignore. Why does the universe appear so precisely tuned for life, and by extension, for consciousness? The physical constants of nature, the strength of gravity, the charge of the electron, the rate of cosmic expansion, all fall within narrow ranges that allow matter to form, stars to burn, and chemistry to exist. If any of these parameters were slightly different, the universe would be lifeless. It would expand too quickly for galaxies to form, or collapse too early for stars to ignite. This apparent precision is known as fine-tuning, and it raises profound questions. Is it coincidence, necessity, or something deeper? The anthropic principle offers a subtle answer. We observe a universe compatible with life because only such a universe could contain observers. In other words, our existence selects the conditions we can perceive. At first glance, that sounds tautological. We're here because we can be here. But its implications run deeper. The anthropic principle suggests that consciousness and the cosmos are intertwined. Our awareness is not an accident, but an inevitable outcome of certain cosmic parameters. Some versions go further, proposing that observers are essential to reality itself. This echoes ideas from quantum mechanics, where observation appears to influence physical outcomes. According to the standard interpretation, quantum systems exist in multiple potential states until measured. The act of observation collapses these possibilities into a definite reality. If consciousness plays any role in that process, even indirectly, then the observer becomes part of the machinery of existence. The universe, in this view, is not a static object unfolding independently, but a participatory system, one that requires awareness to define its state. Physicist John Wheeler called this the participatory anthropic principle. He envisioned the cosmos as a self-excited circuit where observers arise within the universe and in turn bring it into focus. Reality, then, may be a feedback loop between mind and matter, each giving definition to the other. From this perspective, consciousness is not a late byproduct of evolution, but a fundamental ingredient, co-arising with the cosmos itself. The universe may have been structured from the outset to generate self-awareness, not intentionally, but inevitably, given its laws. If this is true, then consciousness after death might not require individual survival. Awareness could be a universal field, temporarily localized within each being. When the body ceases, that local configuration dissolves, but the underlying field remains. To visualize this, imagine waves on an ocean. Each wave has a distinct shape, height, and motion, but all are expressions of the same water. When a wave subsides, nothing truly vanishes. The ocean simply reconfigures. Similarly, consciousness may be a continuous medium, with minds as temporary patterns upon its surface. This notion aligns with certain interpretations of quantum field theory, where particles are excitations of underlying fields. If consciousness is emergent from such a field, perhaps tied to information, space-time geometry, or quantum entanglement, then it could pervade the cosmos. Individual experience would then be a localized phenomenon, not an isolated one. Skeptics argue that invoking cosmic consciousness risks blurring science with metaphysics. Yet the anthropic puzzle remains. Why should the universe's laws be so precisely balanced for awareness to arise? If consciousness were irrelevant, we might expect a chaotic cosmos with no stable observers. Instead, we find one where complexity, structure, and perception flourish. Some physicists suggest the answer lies in a multiverse, an ensemble of universes, each with different constants. In this scenario, we happen to inhabit the rare one compatible with life. No design, no purpose, just probability. Consciousness in that picture is a statistical fluke. However, even if the multiverse exists, the anthropic question persists. Why does any universe at all contain observers? What underlying principle allows reality to generate awareness? Probability alone cannot explain the emergence of subjectivity, the feeling of existence. Consciousness, after all, is not just a feature of physics. It is the lens through which physics is known. Every equation, observation, and theory arises within awareness. Without it, even the concept of universe would be meaningless. This circularity challenges materialism. If consciousness depends on the universe, yet the universe only becomes known through consciousness, then neither can be fully separated. They form a reciprocal whole, two aspects of one reality. That realization reframes the question of what happens after death. Instead of asking where your consciousness goes, we might ask, what happens when the local perspective dissolves into the universal one? If awareness is fundamental, then death does not annihilate it. It merely releases it from a specific configuration. We can compare this to light passing through a prism. The prism splits the beam into many colors, each distinct, yet all part of one spectrum. The individual colors represent personal minds, while the light itself is consciousness. When the prism shatters, the colors vanish, but the light continues unbroken. Some thinkers, like physicist Roger Penrose, have speculated that consciousness may be rooted in the fabric of space-time itself. He suggests that quantum processes in microtubules, structures within neurons, might link awareness to the geometry of reality. If so, then death might dissolve the boundary between individual experience and the universal field. Others argue from information theory. The universe, they say, is fundamentally informational. Every particle and force a pattern of encoded data. Consciousness could be the system's way of reading itself. In that case, awareness is not confined to brains, but woven into the very logic of existence. In this view, when the brain ceases, the information it contained does not vanish. It disperses into the larger informational fabric. The subjective thread ends, but the informational continuity persists. You, as a unique pattern of perception, would fade, yet the essence of awareness that enabled experience remains. Still, caution is warranted. Many of these models stretch beyond empirical testability. They blur science with speculation. Yet even speculative thought can clarify boundaries, showing us where knowledge ends and mystery begins. From an epistemic standpoint, the anthropic principle reminds us that consciousness and cosmos cannot be fully separated. Every observation is shaped by the observer. The universe is not merely out there, it is also within, reflected in every act of perception. This has ethical and existential consequences. If consciousness is woven into the universe, then each mind is a participant in cosmic self-awareness. Death may close one viewpoint, but the totality remains conscious through others. In that sense, awareness never truly disappears. It simply shifts its locus. Such thinking does not guarantee personal immortality, but it reframes mortality itself. The end of the self need not imply the end of being. Instead, existence may be an ongoing process of emergence, where consciousness continually arises in new forms and contexts. Viewed this way, death is not an erasure, but a reconfiguration. The universe folding one expression of awareness back into its depths, even as new ones unfold elsewhere. Each life is a brief aperture through which reality beholds itself. When it closes, the seeing continues, through other eyes, other minds, other worlds. If we accept that the cosmos and consciousness are intertwined, then death becomes less a fall into nothingness and more a return to the background field of knowing. The universe, through us, becomes aware of itself, and through death, awareness merges back into its source. The anthropic perspective thus bridges physics and introspection. It tells us that consciousness is not merely in the universe, but the means by which the universe is known, and perhaps, in some deeper sense, the means by which it exists. Every experience we have unfolds within time. Thought, perception, and identity depend on it. We remember the past, anticipate the future, and call this movement existence. But what if consciousness is not simply in time, but something that defines how time is experienced? And if time itself is not what it seems, what happens to awareness when the temporal flow ceases? Physics tells us that time is not absolute. In Einstein's relativity, time bends and stretches depending on motion and gravity. Events that seem sequential from one vantage may coexist from another. The universe, viewed as a whole, might not be a flowing river, but a static landscape, a block universe where every moment, past and future, exists simultaneously. In that model, death does not erase a person from existence. It simply marks a boundary in the temporal dimension. All the moments of a life, every thought, emotion, and perception remain embedded within space-time like frames of an eternal film. From within the movie, time flows. From outside, the entire story already is. Consciousness, then, could be understood as the traversal of attention through this four-dimensional landscape. Each moment of awareness illuminates one region of space-time, giving the illusion of motion. Death would not destroy those illuminated points. It would merely mark the final frame that consciousness experiences sequentially. If that's true, then your life, every instant of it, still exists within the structure of the universe. From a timeless perspective, nothing truly passes away. The sense of before and after is a feature of perception, not reality itself. But what is it that moves through time? The brain generates a model of continuity by linking memories together, constructing a narrative self. Yet neuroscience shows that consciousness may be a sequence of discrete moments, stitched into coherence by memory. Between these frames, there may be brief gaps, unnoticed pauses in the stream. This has startling implications. If awareness is reconstructed moment by moment, then the continuity we call life is a cognitive creation. The self is not a solid entity, but a process of remembering. Death, in this sense, is the final break in that chain. The narrative ceases, but the moments remain. Entropy, the tendency toward disorder, gives time its direction. It ensures that we remember the past, but not the future. The brain's computations depend on energy flow and irreversible change. Consciousness thus inherits time's arrow. We experience a forward-moving world because physical processes unfold asymmetrically. However, if consciousness is more than its neural substrate, if it reflects an underlying informational or quantum field, it might not be bound to entropy's direction. From that vantage, all moments could coexist in superposition, accessible outside linear flow. Consider dreams. In them, entire narratives can unfold in seconds. Time becomes elastic, molded by awareness. Similarly, in near-death experiences, people often describe timelessness, a sense of being outside sequence where past and future merge. This suggests that temporal perception may be an emergent property of the living brain, not a fixed aspect of consciousness itself. When the brain ceases, the mechanism that orders time collapses. What remains, if anything, could be awareness without sequence, not experiencing next, only is. From within life, such a state is incomprehensible. We define experience through change, but perhaps beyond death, awareness returns to a timeless substrate, one that does not move, but simply contains all possibility. Quantum physics complicates the picture further. At fundamental levels, particles do not evolve deterministically in time. They exist in probability states. The transition from potential to actual occurs only upon interaction, a kind of selection. If consciousness participates in this process, it may not follow time's arrow rigidly. Instead, it might sample reality from multiple temporal directions, collapsing possibilities into an experienced order. If so, the apparent beginning and end of consciousness could be local phenomena, boundaries in one reference frame, not in all. Just as two observers in different gravitational fields measure time differently, consciousness may experience continuity in ways not visible to external measurement. Death might look like cessation from outside, yet internally correspond to a transformation of perspective. Some theories even suggest that consciousness could access non-local information, awareness not confined to a single timeline. These ideas remain speculative, but they challenge the notion that time defines consciousness. It may be the reverse. Consciousness defines what time feels like. Memory plays a crucial role here. Without memory, there is no flow, only isolated now moments. The continuity of self depends on storing and retrieving information. When memory ceases, as in amnesia, identity fragments, yet awareness persists. This reveals that the core of consciousness, the simple fact of experience, exists prior to narrative. If consciousness endures beyond death, it might do so in this minimal form: pure awareness without story or duration. Not I am me, but simply I am. In such a state, the distinction between moments could dissolve, leaving only timeless presence. From the standpoint of relativity, such presence would not occupy a moving point in time, but exist across it. Your entire lifetime could be experienced as a single gestalt, every moment simultaneously available. From within the body, that's impossible. From outside time, it may be natural. This resonates with reports from altered states of consciousness, meditation, and near-death experiences, where individuals describe perceiving all events at once, as though time had collapsed into eternity. While neuroscience can attribute such phenomena to disrupted brain activity, they nonetheless hint that our ordinary sense of time may be a narrow projection of a broader reality. Entropy ensures that physical systems move toward disorder. Life resists this, temporarily creating order at the expense of environmental entropy. When life ends, order dissipates. Yet information theory tells us that information, once encoded in the universe, cannot truly vanish. It transforms. If consciousness is linked to information, then perhaps its dissolution is not destruction, but redistribution. Every moment you have lived, every pattern of thought, is encoded in the universe's structure. The energy and information your body once maintained continue in altered forms. At the very least, the imprint of your existence remains etched into the cosmos. And if consciousness is tied to these informational configurations, then in some deep sense, every experience you have ever had still exists. This leads to a remarkable thought. Perhaps you never truly leave the moments of your life. They persist eternally within space-time. What we call after death may simply be absence of access, the inability to move to new moments, while all previous moments remain real. In the block universe, death is not an event of annihilation, but a boundary condition. The observer's trajectory ends, but the observed timeline endures. You do not disappear, you become complete. From the cosmic viewpoint, your life remains forever inscribed in the geometry of reality. That may sound poetic, but it aligns with physical reasoning. Space-time does not delete past events, it contains them. The birth of a star, the first breath of a child, the final heartbeat, all coexist in the fabric of the universe. The flow of time is how conscious beings traverse that fabric. So what happens when the traversal stops? Perhaps the spotlight of awareness, which once moved steadily along one path, diffuses into the total field. From localized perspective, that feels like an ending. From the universal perspective, it is absorption into timelessness, the light no longer focused through a narrow slit, but expanding to illuminate all. This does not imply personal survival in the traditional sense. The narrative self, tied to memory and causality, would dissolve. But the underlying awareness, the capacity to witness, might persist in a form beyond succession, beyond before and after. Our language struggles to capture this because it is built on time. Every verb assumes motion, every thought assumes duration. Yet perhaps consciousness in its purest form is not a sequence, but a totality, one that perceives time rather than inhabits it. Seen through this lens, death is not the extinguishing of consciousness, but the cessation of temporal filtering. What remains is undivided awareness, not personal, but universal, existing outside measure. In life, we experience moments passing like beads on a string. In death, perhaps the string itself is seen all at once. The illusion of continuity gives way to a deeper continuity, one not bound by sequence, but by wholeness. Throughout our exploration, we've approached consciousness as one of the universe's most extraordinary phenomena, the light by which all experience becomes known. We have examined it through neuroscience, quantum theory, information, time, and cosmic structure. We have seen that consciousness, though intimately tied to the brain, cannot be reduced to simple matter. It is both local and vast, fragile and enduring, bounded yet unbounded. When we ask what happens after death, we are really asking what becomes of this light, the presence behind thought, memory, and perception. Science shows us that when the brain ceases, the electrical and chemical patterns that sustain awareness collapse. Yet the deeper mystery remains. How does the subjective experience, the sense of I, relate to these patterns? And when they fade, does the light fade with them, or does it return to a broader field that underlies all existence? Each perspective we've examined offers a fragment of understanding. From neuroscience, we learn that consciousness depends on integration, the coordination of information across vast networks of neurons. From quantum theory, we glimpse that observation and measurement are woven into the fabric of reality, hinting that awareness may not be an accident, but a structural element of the universe. From thermodynamics, we see that life temporarily resists entropy, maintaining order until it dissolves. Yet the information that once formed a life, every photon, atom, and interaction, never disappears. It simply transforms. If we step back and view existence as a field of information, Consciousness could be seen as the way reality experiences its own order. Every mind, every moment, is a unique expression of that field. When one expression ceases, the information returns to the totality, not lost, but reabsorbed. This view does not promise personal immortality, but it does suggest that awareness, as a universal process, endures beyond any single life. Physics tells us that in the grand tapestry of space-time, every moment of your existence still exists. From the timeless perspective of the universe, nothing is erased. The child you once were, the experiences you lived, and the final instant of your awareness all remain etched into the cosmic fabric. Death is not an obliteration, but the completion of a pattern. The stream of consciousness that once flowed through your body becomes part of a larger stillness. From a biological standpoint, consciousness arises from complexity. The human brain, with its billions of neurons, generates a coherent world by integrating a perception, memory, and prediction. But consciousness is not static. It fluctuates every night as we dream, dissolving into symbols and sensations, reorganizing itself. Death may be a similar dissolution, not into chaos, but into another mode of existence we cannot yet conceive. Even within life, the self we think of as continuous is constantly renewed. Neurons die and regenerate, memories reshape, identities evolve. The you that wakes each morning is never the same you who fell asleep. Consciousness is a river that never holds the same drop twice. And when the river meets the ocean, when the boundary of individuality dissolves, perhaps the flow doesn't cease, but expands beyond measure. Some theories describe consciousness as fundamental, inseparable from the structure of reality itself. If this is true, then individual awareness is like a localized ripple in a cosmic sea. The wave subsides, but the ocean remains. In this way, death could be a return, not of personality, but of presence, merging back into the background awareness that pervades everything. Others suggest that the illusion of a self is a product of memory and prediction. The brain constructs a model of continuity to make sense of experience. When this model ceases, the illusion fades, but the raw capacity for experience, the simple knowing, may be more primal than any constructed identity. If consciousness is the ground from which all phenomena arise, then it may never be destroyed, only transformed. Still, science remains cautious. We can map neural activity, record dying brains, and measure patterns, but subjective experience resists quantification. Consciousness is first person, while science observes from the third. That gap between what is felt and what is measured may never close entirely. The question of what happens after death is not only empirical, but existential. It asks not merely how the brain ends, but what awareness itself fundamentally is. Across our journey, one insight emerges clearly. Consciousness is not a thing we possess, but a process we participate in. It is the ongoing unfolding of reality observing itself. When this particular viewpoint, the body, the memories, the self, dissolves, awareness continues elsewhere, through other eyes, other minds, other lives. The universe remains conscious, even when one expression of it fades. In this sense, death may be neither extinction nor continuation, but integration, the return of a localized awareness to the universal process that birthed it. The light that once illuminated your world does not vanish. It diffuses into the vast radiance of being. The story ends, but the storyteller remains, endlessly re-expressed. Science cannot yet prove this, but it allows the possibility. Information is never truly lost, only transformed. Patterns re-emerge, systems reorganize, and from the ashes of entropy, new order arises. Consciousness, as the apex of complexity, may be the universe's most refined pattern, one that continually reincarnates in different forms as matter learns to know itself. So what happens to consciousness after death? From one perspective, it ceases, the brain quiets, the story closes. From another, it transforms, the pattern diffuses into the informational field. And from a still deeper perspective, perhaps consciousness never belonged to us at all. It was never yours or mine, only a single current in the infinite stream of awareness. When it flows elsewhere, nothing is truly lost. In contemplating death, we glimpse the unity of life. The end of experience reminds us that awareness itself, the capacity to know, to feel, to be, is not confined to one form. The cosmos has given rise to countless minds before, and will again. Consciousness is not a fragile anomaly. It is woven into the nature of reality. As you rest now, allow these thoughts to settle gently. You do not need answers, only wonder. The same awareness that listens now is part of a continuum stretching through all life, all time, all space. It has taken this form for a while, your memories, your emotions, your sense of self, and one day it will return to silence as it has countless times before. But in that silence, nothing is lost. The essence that allows you to dream, to love, to question, it belongs to something larger than your body or your name. When this particular story ends, the awareness that carried it will rest within the greater whole, waiting to rise again in another form, another mind, another world. So as you drift towards sleep, know that consciousness itself is never still. It moves through every atom, every life, every unfolding star. Even in endings, it continues, not as memory or identity, but as presence. The same quiet awareness that watches the breath, that feels the space between thoughts, is the same awareness that endures when all else fades. In this vast and mysterious universe, you are both observer and expression, a temporary opening through which reality perceives itself. When that opening closes, the seeing does not end. It simply becomes whole again. Rest now, knowing that awareness, the light behind your thoughts, has always been part of something timeless, and always will be. Whatever death may bring, consciousness is not its opposite. It is its witness. And like sleep, it is not an ending, but a return, to silence, to stillness, to the infinite knowing that holds all things within it. Good night, and may your awareness find peace in the mystery.